2, but I'm going to break it into 2 pieces. Today we're just going to do adding polynomials. Tomorrow we will continue with lesson 4.2, where we will get to subtracting polynomials. So we're going to do this lesson in 2 different parts. Now, the most important thing, first of all, is to talk about that vocabulary, polynomials. We're going to be starting to use this terminology a lot. You're going to see we're going to be working with polynomials for a while, mostly for the rest of the year. But first, let's start with monomial. Mono, that root or prefix meaning one. A monomial is one term. Monomial means one term. For example, 2x, y squared, -5. Right? So if a term, we've used that, we've talked about combining like terms. A monomial means one term only. A binomial, bi means 2 terms. Now, whenever we have more than one, when I say 2, that means they're going to be added or subtracted. So for example, 3a plus b. 3a is a monomial, b is a monomial. When I try to add the 2 together, I have a binomial. 2 terms, right? Like bicycle, 2 wheels. I could have something like x squared minus y squared. It can be addition, it could be subtraction. You can have exponents, you can have variables. You could even have something that's a little more complicated, like 2xy minus 5, something where there's more than one variable. This is still 2xy, that's one monomial, that's one term. So binomials have 2 terms, monomials have 1, and finally, polynomial. Oh, I'm sorry, I should get to try next. Sorry, trinomial. We will be spending a lot of time with trinomials. You can probably guess a trinomial has 3 terms being added or subtracted. Tricycle. Triangle, meaning 3. So for example, x squared plus 4x minus 7, 3 terms being added or subtracted or both. Right? We can even mix the addition and the subtraction. I'll just stop with that one example. They're all going to look similar to that as a trinomial. And now finally I can get to the one I was trying to get to first. Polynomial is 4 or more, bless you. So technically a polynomial is anything more than a monomial. But because we have specific names for a binomial and a trinomial, I'm just going to use polynomial to mean the ones that's more than 4 or more terms. But really that just means many. Poly means many, just like tri means 3. And so really it could mean anything that's 2 or more, but we're going to mostly see it. Now, an example of a polynomial, let's do it as our first problem because it's going to be kind of long, so I don't want you to have to write it twice. -6x cubed plus 3x squared plus x squared plus 6x cubed minus 5. There is a 5-term polynomial. The instructions for this would say simplify, and that means combine like terms. This is something we have been working on. We worked on it last year in 7th grade. We've been working on it lately. So when I talk about adding polynomials, the first thing you're gonna do is just think about looking for like terms. In this string of 5 terms, this polynomial, which ones are alike? CJ, give me a pair.
Negative x cubed and
Okay, again, looking at the signs that are in front, include the sign with the term. Negative 6x cubed and positive 6x cubed. What's going to happen when I combine those? How many x cubes do I end up with? Diego? 0. Okay, good. We end up with 0x cubed. You do not need to write down something that ends up with 0. You could write that, but no matter what x equals, when we multiply it by 0, it's going to be 0, and it won't affect our answer because of the value of 0. So I'm just going to consider these to cancel each other out because they are opposite signs with the same coefficient. Other like terms that we can find here to combine? Jaden?
3x 2
Okay, 3x squared plus 1x squared with that invisible 1 coefficient. 3 plus 1, I have 4x squared. Notice the exponent does not change. We're not multiplying them. That was lesson 4.1 where we multiplied and the exponent changed. Here we're just saying how many x squareds do I have. Now the negative or minus 5, there are no other plain numbers. If there were, you would combine them. Plain old numbers are like terms. So there's our answer. So that's the first example of a polynomial. Now, here's what you're going to be doing. You are going to be adding them, which means that you will be given 2 different polynomials. For example, 4y minus 2 do parentheses. That's a binomial, right? We've got 2 terms. Plus negative 3y minus 9. Here's what you're going to want to do for these guys. Some of these will be written side by side. If they are, you want to stack them vertically, lining up the like terms. Just like you would line up with numbers, you'd line up the 1's digits and the 10's digits. So let me show you. We would go 4y minus 2 plus, don't forget the negative 3y minus 9. So you want to stack them vertically. Now some of them in your book are already going to look like this, and then you can just copy them the way they are. But if they are written side by side, I want you to stack them vertically. The reason for that is actually more important for tomorrow's lesson of subtraction. But we're going to start using it this way, the vertical stacking today for addition, so that by tomorrow you're more used to that. Now, all we have to do, guys, is combine like terms again. But my like terms are lined up, so I don't have to think too hard about it. Negative 2 plus negative 9. What do I get? Negative 2 plus negative 9. Diego? Good. Negative or minus 11. 4y plus negative 3y. 4 plus negative 3 is positive 1. You can put the 1, but just remember I won't ever show that. 1y plus 11, or minus 11, excuse me. I will show as just y minus 11. Not too difficult, right? Just adding by combining like terms. Let's just do one more. How about 3x squared, bless you, whoops, 3x squared, minus 2x plus 1. Now, the way your book is going to show them if they're already stacked, it won't even have the plus sign to show its addition. It will just have them all lined up like this, and the directions up top will say add. So we know it's adding because it tells us to add. If you prefer to add a plus sign out front to remind yourself that we're adding, go for it. Okay, again, just like we do with regular numbers when we're adding, we start on the right side. We're going to do that here. We're going to start on the right and work our way left. We are just combining like terms. Again, they're already lined up for us. 1 plus 3, 4. Negative 2x plus negative 2x, Negative 2 plus negative 2, negative or minus 4x. Again, I'm just counting how many x's. The exponent doesn't change. 3x squared plus 1x squared, 4x squared. Now, the final thing that I need to point out, I think that you guys can do all of that pretty simply. The only other thing you're going to see in the directions, oh, it doesn't say this actually. However, I just want to point this out. We are going to be seeing the word degree, and this means the exponent number you want to write your answer with the highest degree, the highest exponent number, highest degree first, and then go down from there. Now this one's already in that order. X squared, plain old x, no variable at all. But you might get some where they're jumbled up a little bit. Your answer, the math format for this, is to always start with the highest exponent first. So x squared would come first, then x, and then the one that's a plain number with no variable goes at the end. So just think about that. Might come up in some of your problems today. I don't remember for sure, but that's it for today.